Okay, this is week 2. Last week we talked about the supply and demand. One thing that when you are managing your firms, that you want to know is the demand that your firm is faced with. So what we are going to do today is to cover some techniques that you can use to estimate the demand function, your demand function. And we can do it using Excel. You will be familiar, you will need to know how to specify model, how to collect data, how to estimate the model, the equation, estimate the model, and how to interpret the results and how to apply it in your own context. Okay, we're going to use regression analysis. And clearly, you do not need detailed knowledge of ordinary least squares. Ordinary least square is the technique that we are going to use in this exercise here. If you want to know more about OLS, ordinary least squares, you can do econometric subjects on that. For our purpose, you need to know how to specify model, how to collect data, how to estimate, and how to interpret the results. Okay, what is a regression analysis? It's a statistical technique for finding the best relationship between the dependent variables. So we have dependent variable, A depending on B. So it's dependent variable, and the selected independent variable. So independent variable explain the dependent variables. We could have simple regression, that's only one independent variable, or multiple regressions, several independent variables. So dependent variable, it depends on the value of other variable, as the name suggests. Independent variable, we use them to explain variations in the dependent variables. Okay, let's look at this picture. Suppose here vertical axis is price of goods X. This is quantity X. And we collect this data. When price is at this level, demand is at this level. When price is this level, demand at this level. So we collect all data. Then we want to figure out the demand function. Or in other words, we want to put a straight line that fits these points, these data points, in the best way. Okay, now you need to ask, what do you mean by best way? Or what way is the best way? Certainly, no matter how we put the line into the picture here, we could not let this line pass all the data points altogether. So there's always, for example, I put line here, there's always, for this data point, it's not on the line, so there's always an error here. This error is positive. This error is positive. And for this point is below the line, so the error here is negative, 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 negative. So now, why don't we choose a line such that we get the smallest error? So in this sense, we mean the best way. So we fit the line into data such that the error is the smallest one. Okay, now you need to ask. We have some positive error here, we have negative error here. So ideally we can sum them up. But sum up positive error, but we add positive error with negative errors, then they are going to cancel out. So what we can do is, okay, we square error. We first square this error. So positive error we square, still positive. Negative error we square, it becomes positive. So square this error, then sum them up. Choose the line that fits the data points in the best way. which means minimize the sum of square errors. Sum of square errors. That's what we call ordinary least square technique. Okay, so that's the principles of these OLS regressions. Okay, to use this regression analysis, first step, you want to specify the models. Secondly, obtain the data or variables. Then estimate the quantity relationship and test the statistical significance of your results. And then you can use these results in decision making. First one, specify model. So you are going to estimate demand function. So demand, that's the dependent variable, depends on price. This is demand of X. Here's price of X. For example, let's say this is we want to estimate demand for chicken. So here's the quantity of demand of chicken. Here's price of chicken. Here's the price of Y. Another goods, maybe price of beef. Chicken and beef, they are substitute to each other. And income. And there could be other things, other things. So that's a general functional form. So you can further specify in a linear way. So quantity depends on A plus B1 plus price of chicken plus B2 multiplied price of beef plus so on and so forth. And then there's a mu here. Mu is a random error terms. We call error terms. We assume it to be, usually we assume it to be normally or independently, identically, normally distributed. Okay, so now we don't know what A is. A could be 2, 3, 4, 5, 6, 7, 8, 9, 10. We don't know what A is, what B1 is, what B2 is, what B3, what B4. So we need to collect data, using data to estimate what they are, what the coefficients are. Okay, so now you need to collect data. For example, if you want to estimate this equation, you need to have the quantity of X, you need to have price of X, you need to have price of Y, you need to have income, you need to have H. Get this data? You can either use cross-sectional data. Cross-sectional data is the information collected at one point in time. Or you can use time series data. It's information that you collect over a long period of time, over 1 year, 2 years, 10 years, 20 years. Or you can use longitudinal or panel data. So it's at least 2 different cross-sectional data from one group of people, each collected at different point of time. So in a sense, you combine both cross-sectional and time series together. Then you can estimate a model. You can use some statistical packages such as SPSS, Shazam, or you can use Excel. We are going to use Excel because Excel is handy. Most of people got Excel installed in the computer to run these regressions. And here is an example of typical results. I'm going to show you a bit more later. Okay, let's look at the example here. So that's the data we collect. It's a chicken. We want to estimate demand for chicken. Y here is the per capita income. So this is per capita income. Price of chicken. PC is the price of chicken. PB is the price of beef. And YD, Y is the per capita chicken consumption. It's the quantity of consumption. Y is the quantity of chicken consumption in pounds. And YD here is the U.S. per capita disposable income. It's the income, per capita disposable income. R is the interest rate, real interest rate, in percent. And it is a time series data. We see that it's a time series data because it runs from 1950 to like 1984. So that's the data we have. And we want to estimate this equation. Y is equal to A. A is the unknown constant plus B1 multiplied by price of chicken plus B2 multiplied by price of beef, GB, plus B3 multiplied by disposable income plus B4 multiplied by real interest rate plus the error term. Error term. That's the model. That's the model you want to estimate. Okay, one thing you got to be very careful here is that when you are deciding what independent variable you're going to use, you need to exercise your intuition here, or you need to use your economic knowledge to decide which variables entered into your regression equation. So clearly, what is the quantity of chicken consumption? It depends on price of chicken, which makes sense because no demands, right? Depends on price of beef, which makes sense. Because chicken and beef are substitute to each other. So price of beef increases, demand for chicken will increases. Depends on disposable income. Certainly, the more income, the more dollars I have in my pocket, I might buy more chickens. So this makes sense, intuitive as well. Real interest rate. Okay, this is a bit problem. Why a real interest rate? You got to think when you want to put a real interest rate into the equation here. You got to think why you need real interest rate, or why real interest rate affect the consumption of chicken. Okay, so intuitively we probably think that saying real interest rate is not needed. Real interest rate may not explain the quantity of consumption. So let's just get rid of it. So now we have model. We specify the model. We collect data here. So next step we want to do is to estimate these equations. Okay, how? I'm going to show you how. Okay, here's the Excel. Go to data. Depending on your setup of your Excel, if you already set up, there should be an option of analysis here. But in my case here, there's no this button. So we need to add a button to the Excel. So you click File, Option, and choose Add in, Analysis Toolpack. Select Analysis Toolpack. Okay. No, let me do it again. Option. Yeah, select analysis toolpack. Okay. So now if you go to the data, you're going to find data analysis here. So now you're ready to use Excel to estimate the equation. Click data analysis, and the windows, in the pop-up windows, choose regression, and click OK. And now input Y range here. Y here is the dependent variable, the quantity of chicken consumption. So let's select it. Okay. Note that our selection includes the label Y. label Y, so we need to have this one. Tell Excel that our selection include the label. Input X range is the independent variables. So we have 3 independent variables, PC, PB, and YB. So this thing. Okay. And now you can choose the output range. We are going to let Excel to display the outputs in a new worksheet. So let's say, then we are ready to go. And here is the results, the equation results we have. So how to interpret this result? That's the regression results we have. When you get the results here, first thing you want to look at is R squared. R squared. R squared. R squared is, it measures how good your regression fits the data. So R squared here, R squared is ranged between 0 and 1. So if R squared is 0, that means your regression, your estimation does not fit data at all. If it is 1, that means your regression, your estimation fits the data perfectly. And clearly, we shouldn't expect a perfect fit as a whole. So usually it's between 0 and 1. And here we got 0.97. That's pretty good. That's pretty good. So that's 1 cent R squared. Secondly, you want to check the you want to check the coefficient you estimate, whether they are statistically significant. That means whether they are different from 0 statistically. Okay, how to do that? Let's have a look. So now we have this table. It reports both the coefficients and the standard error here, and also t-stat. So to check whether individual coefficients is statistically significant or not, you look at the t-stat. So if this t-stat is bigger than 2, absolute value 2, if absolute value of t-stat is bigger than 2, then you can say it's significant, it's different from 0 statistically. Okay, so clearly for intercept, coefficient of price of chicken, coefficient of price of beef, coefficient of income, they are all significant, So basically this table says that we estimate this equation as this. Y is equal to roughly 31.26. So that's the intercept here. Plus minus here, 0.8 multiplied by price of chicken, plus 0.21 multiplied by price of beef, plus 0.002 multiplied by YP. So that's the equation we estimate. If you want to convert from the table format into the equation format, that's what it means. Okay, and t-stat here, they are all significant. Okay, so that's the result. Two things you want to look at when you get the outputs. First one is R squared, second one is whether individual coefficients is significant or not. Okay, now we are ready to interpret the results. First thing is our estimation. Does our estimation make sense? Let's look at the price of chicken. Well, we are reasonably, economic theory tells us that price increases, demand decreases. So by lower demand, we call lower demand. So price increases, demand decreases. That means the coefficients need to be negative. So indeed it's negative. So price of chicken increases, demand for chicken decreases. So this indeed makes sense. Makes sense. What about price of beef? Beef and chicken, they are substitute to each other. So if price of beef goes up, so people must walk away from buying beef to buying chicken. So demand for chicken will goes up, right? So it's indeed positive. So it says that they are indeed substitute to each other. Price of beef increases, demand for chicken increases. Income, disposable income. The coefficients we estimate is positive, significantly positive. So it says that income increases, demand for chicken will increases. So that makes sense as well. Okay, so that's the result. That's how to interpret this aggregation results here. Okay, that's the coefficients we estimate. And now you can calculate, you actually can calculate the associated elasticity. Okay, let me move it down a little bit. So that's the equation. So let's say you can calculate elasticity. So price elasticity of demand. Here's the price of chicken, price of demand. We know that epsilon E is equal to percentage change change of quantity. Here is change of y. We use y to denote quantity or percentage change. Percentage change of quantity divided by percentage change of price chicken. Okay, and this is equal to slope of the inverse demand. So that's the slope. Multiplied by PC over the quantity. Okay, so that's the equation. So, which is basically, because the demand we have is a linear demand, it's a straight line. So the elasticity is going to depend on which position we are on the straight line. So let's say it depends on PC and Y. So that's E. So if suppose PC plus is equal to let's say chicken, let me look at it first. Price is 22.2. We have this income. And the quantity of consumption is 20.6. So that's what we have. So that's Y. And what's the associate elasticity here? So it's equal to slope here. It's equal to slope here. So slope we get here is minus 0.8. Minus 0.8 is the coefficient again. So it's equal to minus 0.8. You can ignore the negative sign because we know it's negative. 0.8 multiplied by PC over Y. So PC is C is 27 divided by B 27. B 27. So that's elasticity. Okay, let me. How many digits? You just want it at 2-digit level. And clearly, you can calculate for all other combination. Let's see. So at this point, the price elasticity demand is 0.86. So it's actually inelastic. When you pull it down, you get all the associated price elasticity of demand. So that's how you can calculate elasticity from your equation there, from your estimate equation. Okay, so that's the regression analysis. That's the regression analysis. When you're running firms, certainly you would like to know more into the future. So you need to forecast in the future. There are several techniques that you can use to do the forecasting job. First one is expert opinions. For example, you want to forecast your sales. Then you can say ask experts in your field, ask your production manager, ask your sales manager, and ask for their opinion on how many dollars are you going to sell, how many dollars your sales revenue is going to be for next year. And one man says 20 million, and another man says 25 million, and from here you get a forecast. So that's expert opinion. You can also survey and do market research. For example, you can do a consumer surveys. You can say do a consumer survey in the shopping mall. Ask people, say how many bananas are you buying? How many kilograms of bananas are you buying every week? And when you get a survey, you add it up, you get an idea of the possible sales of bananas for your firms. You can survey people's spending plans. Ask people how much they are going to spend on this item, how much they are going to spend on another items. You can look at economic indicators. Government agencies such as ABS, Australian Bureau of Statistics, or Central Bank, Reserve Bank in Australia, they publish regularly different economic indicators, for example, like GDP, like unemployment rate, these sort of indicators. And these indicators generally give you an idea of how the macroeconomy is running. So if all indicators goes well, for example, GDP is growing at 10%, and unemployment rate is low at 4%, then certainly you can expect that next year the economy will be doing well, and which means that your company, your firms is likely to perform well as well. So you can use this economic indicator. Using this sort of economic indicators, you can have a theme into the future. Okay. You can use projection. You can say you observe if you are going to forecast your sales into the future, and clearly you observe the sales of your firms in the past few years. So you can make projections into the future by looking at your past. Or you can use econometric models. Like previously, we estimate the equation, the demand function for chicken data. So if you say, we got this one, we got You got this equation? You got this equation? So if you assume that say the price of your chicken next year is going to be $20 per kilo, and beef is going to be $25, and people's income will increase by say 20%.